Okay, the Testo 557S, and now we're testing the evacuation decay test mode. And as you can see, I already have it running. I'm going to turn it off and set it up in front of you again. I have not read the instructions. I'm going to try to go through every feature on this gauge without reading the instructions, because if they did their software set up correctly, so it's like logical and goes like in a nice intuitive method to follow, not really complicated, a person should be able to operate all the software without reading an instruction manual. If you can, then they did their homework and they actually produced a good piece of equipment that has good software. Because before, you know, sometimes software wasn't so good before and people didn't like it because of that. So what you see here, here's the Testo 552i, the vacuum gauge, and this connects up to this gauge so you can do a data graph, a logarithmic graph over time and duration with your graph. So what you see here, I actually started this one at, I think it was about 114 microns is where it was at. I don't know why. I guess it fell up so fast that you can't see that it was below 200 microns, but it was actually at 114. And when I started this graph going, and I had the vacuum going, so because I wanted to see a little flat graph and then go up, but I guess it didn't do that. I guess I have to I would have had to not turn off the vacuum, wait 60 seconds or so for there to be a straight line first before it going up. So what happened was, as you can see here, from 114 to 500 microns, it lost its vacuum that fast. But why do you say it lost? Remember before, when I did my test before, it held overnight. But look what I have on here. I have rubber hoses. So right now, all I did was I put rubber hoses, just like you would use on a test, which you're not supposed to use. Remember, you're not supposed to use a refrigerant manifold gauge set with rubber hoses to do a vacuum decay test. But people insist to, so I'm going to show you what happens. If you've seen my last videos with a copper line, using copper lines like this right here, see, I replaced the hoses with copper line here that was on this one here. If you use all copper, you don't lose through the rubber, and you don't have the outgassing of the rubber and the slight leakage of the rubber. So this is just showing you how much leakage there is from the rubber and why you don't use refrigerant manifolds to do a prolonged vacuum decay test. And so let's go through the whole procedure right now. As you can see through this rubber hose right here from the gauge, we have 1,256 microns. This has a solenoid valve. If you lose power, you turn it off, it closes internally so it doesn't back bleed air into your system. That's a safety measure. That's a nice thing to have. If somebody kicks your extension cord out while you're pulling a vacuum, you had it on there for 8 hours, and you lose it all because somebody kills the power or something like that, and it sucks air into your system and back feeds in, or worse yet, siphons out the oil out of the reservoir into the system. I actually had that happen to me once. Somebody did that to me, kicking the cord out. So let's go through this. Let's kill this test. So let's just completely stop, shut it off. Okay, and now we'll start from square one. So I already have the gauge turned on. Let's see if I can get it over here so you can see it. You can see it blinking. So we won't bother with the vacuum gauge. We'll just turn it on and we'll go right into the vacuum decay test. Let's open it up too. Let's lose our vacuum. So we're starting with a reference. There we go. I just heard it bleed off. And there it goes. It just went to 0. So let me tighten that back up. Okay. And you can see the little Bluetooth symbol right there. So now we're going to go into vacuum mode. So let's go to menu. Menu. We're going into measuring mode. measuring mode. Now we're going to go down to evacuation. Use your arrow down keys. See, this is intuitive. This is very simple. One arrow down, we're into evacuation. So let's hit enter. And this is what I set the inputs, manual input. And so if you want to set these to higher or lower, so here's my maximum decay test of 500. And this is my evacuation target. I want to get down to this one. Well, let's say I want to lower my evacuation target. Let's go down to like 180. Menu. I selected it, and let's go down. And if you hold it, it'll eventually see there it goes fast. Okay, so I'm at 100. That's my evacuation target test. Now, what I didn't notice before, I heard no alarm when it hit the evacuation alarm test. I thought I was going to hear an alarm. So I changed that. So now hit menu. And now let's hit arrow, because you see this is blacked out right now. So that's where your selection is. Let's menu down. Now if I wanted to raise or lower this, usually I set mine at around 200. I like to get my vacuum usually normally gets down below 100. And my vacuum decay, I like around 200, 240. 500 is if I'm on a used system, or definitely a car. It's too difficult to go below 500 on a car. So any of you automotive guys, don't try to shoot for going below 500 on a car, especially if you have a normal vacuum pump or you're using a big machine or anything as your vacuum source, because you just will barely ever get there, especially when you're using just rubber hoses and they're contaminated with moisture laden to oil. I discussed that in other videos, that once you get ester oil inside your hoses and they've been exposed to the atmosphere, you have a ton of moisture just coating the entire inside circumference of your hose. All that oil is completely saturated with moisture. So let's go down to OK, get out of here. We hit OK, menu. Now we're into evacuation test hold. So remember, I tightened this. I have this open, this is open, open, open. All these are nice and tightly sealed. There's no air leaks. There's nothing. These are not used, broken up hoses that are all bent in a house. These are brand new hoses. Yellow jacket +2 hoses, so they're not the cheap hoses. And you can see we're at atmospheric pressure here because this has all lines right there. So let's you could hear me watch right here. Just hit that. Let's see how fast it's going down. We're already below 100 microns, and we're at almost 500 microns here. So this is reading vacuum here. This is reading vacuum there. 12.1110 microns. You can see we're still at 300 because you have the hose loss. You have all the losses in this hose. You have the friction going through reduced ends, going around corners and coming back over to the sensor that is here. So this through Bluetooth is reading from the sensor here to the sensor there. Now if I was to take this vacuum micron gauge and put a two-way valve on it and screw it into there, into the end of one of these hoses, and bring it out another 36 inches, 60 inches, whatever the length of the hose is, this number would be higher right now. Say it would be like 400 and some microns at the end of one of these hoses, because you would have the loss of the refrigerant hose. There's actually, the farther you get away from the vacuum source, the more your losses are. And so you got length, diameter, and then contamination. Whatever the level of moisture and outgassing from used rubber hoses are, from having moisture and refrigerant saturated into the rubber and stuff like that, you would even have a higher number that would take a longer time to get down, because it would have to remove the contaminants of moisture and outgassing refrigerant before it can bring the level of the micron level start falling down. So you can see where it is. Now, as you know, very few guys ever get down this deep on a large system. You can do it, it just takes time. Now if it's a large used system and 6 guys worked on it before you, possibly opening the system up to the atmosphere and just leaving it open while they were working on it, you're not going to get your vacuum down. There's just too much moisture in a system that has ester oil in it. Now as you see, we're approaching that 180. I had it set at 180. Now since I had it set at 180, I expected their alarm to sound, but I never, when I performed this test prior to taking this video, right there, I just hit the 180. I would think that an alarm would go off right now. Okay, so we're gonna perform the vacuum decay test. So here where it says start, that arrow button, boom, start. So now we have the graph came up here and it's ready to graph out the time. And we're at 171 microns, but as you can see, looking below the 200 micron mark, you don't see no graph starting. There's no line coming out. You would think there'd be a line moving along, but I don't see anything unless it's behind that little arrow right down there. If it's coming in behind there, that's at the 200 mark. So let me shut off the vacuum source and let's see where it starts at. If I can get that my camera lens or camera light out of your lens so I'm not blinding you with reflection. Okay, so right now I'm turning off the vacuum source. Oh, and let me show you right now. So we're at 170 and we're way down there. I mean, we're down to almost nothing at the gauge. So let me turn off the vacuum source and watch me turn off. Okay, there, the vacuum source is off and it's rising. Now count the time. We're at 1 minute and 9 seconds when I fully close the valve. Let's see where it hits 500 microns, and that would be a fail if it goes over 500 microns. There, we're over 500 microns in about 20 seconds. So your system failed in 20 seconds. And why did the system fail in 20 seconds? Because we have rubber hoses. This is why you should not use a manifold set with rubber hoses. Unless you've seen my videos before where I use copper, then it passes. It passes with copper, it doesn't pass with rubber. And that's it for this. I just ran you through the vacuum decay test. And oh, let's do another thing. How about if I shut off the rubber hoses right now? So let's reopen it back up. You should see that fall. See it fall right there? Taking a nosedive. So now I'm going to turn off the rubber hoses, and so the vacuum will be trapped within the valving right here, within the manifold, and back down the valving right into the Testo vacuum gauge. So let's turn off the high side hose so we isolate it. And as you see, you're going to see that just dropped down because I just got rid of a rubber hose. So let's turn off the other rubber hose. Boom. And there it jumps down, it dives down at the end. That is how bad rubber hoses. This is why you're not supposed to use, again, refrigerant hoses for performing a micron decay test are not to be used. But yet, many people insist on using them. You've even seen some of my videos when I do them. But I'm only looking for big leaks when I'm doing that. If I'm really looking for a leak, I will have a vacuum gauge, whether it's that one or whether it's the blue vac, attached directly to a port with no rubber in the entire system. So if I'm on a commercial or residential system, there's no rubber seals anywhere. Everything is silver brazed. And my only sealing surface of rubber is that little piece of rubber right there. And when I want to get really crazy, I even remove this and I just use a copper line with a fitting, and I make something up that has no rubber on at all when I really want to be extreme. So there we are. We're down to 50 microns. And this reading is taken from this gauge. There is not a micron meter inside here that is recording your vacuum level. It's coming from here through Bluetooth. So let's turn off our vacuum source and see what happens. Okay, so now I'm turning off the vacuum source. Now it's off. And it should level out after it reaches a certain point before 500, because for the last 2 nights when you've seen my other videos, it did. And if you look at the rate of decay, you're starting to see it starting to bend over. It's not as sharp as it was when it began, and it starts gradually going over. And that rate of decay will start to slow down more, and you'll see it start bending over, and it should level out and then come to a stop. And you start noticing slight pauses in there. You notice go down a little bit and then back up. Okay. So that's a vast difference than when I had rubber hoses on it and I turned it on, and how fast it ran up in a decay. It shot up right past 500 microns. Now, do you notice the pattern of where it's leveling off at? And so normally you do your 10 or 15 minute micron test to make sure you did not exceed. If you're on residential, let's use some arbitrary, what they call a rule of thumb number. Within 15 minutes you did not exceed 500 microns. But if I was doing very cold, extreme cold temperatures, refrigeration, I would want to be my rate of decay not go over, say, 200, 240, depending on your manufacturer. You've seen some of the old refrigeration equipment. In their instructions, they would say pull the vacuum level down, and they don't want their rate of decay to go above like 240 microns. Some of you old refrigeration guys remember reading that kind of stuff. But then you want to draw your vacuum down well below 100 microns to achieve that 240. Whatever you're trying to achieve, you have to come well down below it to get there. And here's the other secret. You know how people talk about that 500 microns? You do not pull a vacuum down to 500 microns and say, I'm done, I have done my job. No, getting to 500 microns means nothing. It's how long you can get there and hold it and get below. Constantly pulling is where you're doing most of your work at removing moisture. And then say 20 minutes, 30 minutes, you'll see it on the gauge. You'll see it gradually come out where it stops doing any more work. And there's no guessing. It's either you can measure it and see it, or you can't. Because you could pull all day long, but if you have a slight leak or really excessive moisture in a large old system that's been in use, you'll turn it off, and without any gauges to being able to read, it'll still have a lot of moisture in it, and you'll never know without being able to read. And that's why if you hit 500 microns, now start your timer and go away and have your lunch break for a half hour or an hour after you hit 500 microns, not that time it took you to get there. If you've seen my videos where it's taken 20 minutes, an hour, and I still could not get to 500 microns because I had systems that were so moisture contaminated, then it doesn't matter if you had it on the vacuum pump for an hour, because you did nothing. You never got below 500. There's still a lot of moisture in the system. And yep, that's off. And we'll turn this off. And the solenoid closes when you turn off the pressure, and you see it slowly come up, but it'll never go to atmosphere. That's just decay inside the hose here. If I had a metal line, this would not be going up so fast. And coming back here, you could see it steadying off, and we're approaching, there's the 10-minute mark right there. You know, I started those just before 5 minutes, around 4 minutes. We're heading to the 10, and it looks like if we went all the way out to here to the 15-minute mark, it looks like the way the decay is tapering off, it'll easily pass the vacuum decay test within a 15-minute period of time. So that's it for tonight. That's a good enough overview of this procedure. I'm wondering if it could cast this through here onto a piece of software on your laptop or a little iPad or something, just like the BlueVac software does. For that, I will probably have to read the manual. I expect to have to read the manual to see if I could get it to do that. Well, it looks pretty good. So far, I'm still like that. I still have not figured out the reason why I have that like boot loop with the refrigerants, updating refrigerant, and it keeps going over and it makes my phone unuseful because it keeps boot looping into refrigerant updates and it doesn't stop. I still haven't looked into that. I haven't got that far. I just wanted to get this thing to make sure it could hold a vacuum and not bleed by the O-rings inside here, by the manifold itself, before moving on to other tests. Alright guys, see you later.